All right, guys, welcome to our last Monday together. So sad. The time went by so fast. So today we're going to be in our journal notes. It's over Pythagorean Identity, notes 33.1. So as you can tell by the title, we'll be talking about the Pythagorean Theorem today. So before we get started, I want to review with us from last week, sine, cosine, tangent. So we did sine, cosine, tangent last week. So let's talk about that. So you learned in geometry class, SOHCAHTOA. Let's review that real quick. So SOHCAHTOA, so sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent. Okay, just a little review from geometry and then last week. So you need to know this for today's lesson. Okay, then let's review also what we learned last week. So last week we talked about the unit circle, or the beginnings of it, with the radius of 1. So let's talk about that. Let's draw that. So I'm going to draw a unit circle. I'll draw a coordinate plane. So I'm going to draw that here. Okay, so then what we did last week, we drew like a radius of 1, like this was 1, and then we drew a right triangle, and like this was the reference angle right there. That was the measure, theta is the measure of the unknown angle. So you can write that, like theta is measure of unknown angle. Okay, so theta is what you're looking for. Okay, then we talked about this is your x distance, this is your y distance, and on a unit circle the radius is 1. So like you have like a circle, right? Like something like this. Well, that's pretty good. Okay, hopefully you can see it. Okay, so radius of, it's a unit circle, radius of 1. Pretty good. Okay, so there is 1. And then we talked about, let's do sine cosine of that. So it was like sine theta is what? Opposite over hypotenuse, so y over 1. Cosine theta is adjacent over hypotenuse, so x over 1. Then tangent theta is opposite over adjacent, so y over x. Okay, so that's a review from there. But then let's go one step further. Okay, well, y over 1, anything over 1 is itself. So we just said this was y. Remember, so sine is equivalent to y, and then cosine was equivalent to your x distance. Well, then we also could talk about, well, what is y? Y is equivalent to sine. So now we can refer to tangent as y over x, or we can refer to tangent as sine over cosine. Those are all really, really important. Okay, so then we also talked about, then if theta is the measure of the unknown angle, you're looking for this point right here. You're looking for x, y. Because the point xy is the distance here, x, and the vertical distance, y. So we talked about last week, like x, y. So x is your cosine, and sine is your y. So cosine is your horizontal distance on the unit circle. Now this is only with the unit circle because the radius is 1. So this is, we are dealing with the unit circle. Radius is 1. So this only, right now in the beginning, is only with the unit circle where the radius is 1. That's why this works. Okay, so sine is y, cosine is x, tangent is y over x, which you do use that in pre-cal a lot, or you also can use sine over cosine. All right, then let's go back to geometry class. Okay, so geometry, it's going to be what? Pythagorean Theorem, the title. So it's x squared plus y squared equals 1 squared. So we have x squared plus y squared equals 1 squared, right? Well, let's just do substitution. What's substitution? Substitution would be, well, instead of x, you would say cosine squared, right? So x squared plus y squared. So you can say cosine squared theta plus sine squared theta equals 1. And I'm running out of room, so I'm going to turn the page. Okay, let's move on. So what did we just create? So we just created, I'm going to go here. We just created the Pythagorean identity. So Pythagorean identity is our foundation. You will use this a lot next year. So that is our foundation. So I'm going to do it again. So Pythagorean identity comes from, well, Pythagorean identity is this. It's sine squared theta plus cosine squared theta equals 1. Or it's interchangeable. Either way, cosine squared plus sine squared equals 1. And where is that coming from? That's coming from the unit circle that we just did together. So that was coming from the y squared plus x squared equals 1. Okay, so that's the Pythagorean identity. Sine squared plus cosine equals 1. All right, now let's use this Pythagorean identity. Okay, so there's two ways to do this. Now we're going to find either sine or cosine. So let's see, we'll start something basic. All right, so first example. First example we're going to do is we're going to say cosine theta equals -3/5. And it's going to say find sine theta and tangent theta. That's what we're looking for. Okay, but it's also going to tell you, because think about cosine. Cosine, if you go to the right, x is positive when you go to the right, and x is negative when you go to the left, because x on the coordinate plane. So then it's going to tell you, given that theta is between pi halves and pi. Okay, so theta is between pi halves and pi. So you need to go back to last week's lesson and let's think about that. Where are you located? So if we want to, we can draw little triangles so you can see what we're talking about. So remember, this is 0, this is pi halves, and this is pi. So this is 180 because 180 is pi, and this is 90, and 90 is pi halves. So that's from last week. Okay, so we know that our theta is going to be in this right here. So if you want, you can just draw an angle, and there's the right triangle. There is theta. That's theta. Well, it says cosine is 3/5. Well, cosine is adjacent over hypotenuse, right? And it's negative because this is the negative direction. So then we're looking for y, right? Because we want to find y in order to find sine and cosine, or sine and tangent. Okay, so what is sine? Sine theta is, well, we all know this is a 3, 4, 5. So sine is opposite over hypotenuse. Then tangent theta is what? Y over x. So y over x is going to be what? 4 over 3. Okay, here's the part that you need to go back and check. So in this quadrant, what is it? X is negative, y is positive, right? That's important because in this quadrant, x is negative, y is positive. Well, it's going to be positive 4 over y, so the hypotenuse will always be positive. And then tangent is going to be y over x. Well, this is negative right there, so that 3 is negative, but you don't normally write like that, so the answer is going to be -4/3. So you have to do your signs. Make sure you do your signs. Always check your signs. Check your signs. That's really, really important. Because in a multiple choice test, which I've seen, And then even with me, like if you don't have the sign correctly, you'll get that kind of wrong. Okay, well, let's incorporate the Pythagorean identity. So the Pythagorean identity is going to be sine squared theta plus cosine squared theta equals 1. So what is sine? Sine is what we're looking for, right? So it's going to be sine squared. So what I'm doing now is just another way. So this is another way. Using Pythagorean, identity. Okay, so sine squared plus, and cosine squared is negative 3 squared equals 1. And now you have kind of like an algebra problem. So quickly, sine squared theta plus square that is 9 over 25 equals 1. Then if you subtract sine squared theta, well, this is going to be 25 over 25. So 25 over 25 minus 9 is going to be 16 over 25. Take the square root. Opposite of square is square root. So it's going to be sine theta equals square root of 16 over 25. So sine theta equals 4 over 5. But sine is going to be what? Y is going to be sine is positive because y over 5. So positive is the right answer. So there's two ways to do this type of question. One is using the Pythagorean identity, which is the title of the lesson. So it's going to be sine squared plus cosine equals 1. So using the Pythagorean identity is one way to do it. But I personally would do this way up here. This is a lot faster and more direct. But in the future, you will use Pythagorean identity a lot. So this is why we want to go over the Pythagorean identity, because it's quite useful in pre-cal, because you will use it. But for this lesson today, this is a way to do it. But this way up here is, as you can tell, is way faster, way makes more sense because you can see the picture. But now there's two ways. So let's do one more. Okay, let's do cosine theta is negative 5 over 13. And then theta is going to be between pi and 3 pi halves. Okay, and we want to find sine and cosine. So this is how I approach it. So you can draw the triangle out if you want to, sorry. Okay, so first of all, what you have to do is that your theta is 3. So let's label this again so you know where you are. This is pi halves, this is pi, and this is 3 pi halves. So you need to know where in the unit circle these measures are. Well, if theta is between pi and 3 pi halves, you'll know you're in quadrant 3. So you're in quadrant 3. So that's the first thing I would do is figure out what quadrant that you're in. So because this is the restriction, you're down here. Then what I do is I go, okay, if I'm quadrant 3, what are the signs? Well, the signs in that quadrant are negative and negative. So this is definitely two things you need to do. You need to figure out what quadrant that you're in because the quadrant determines the signs. Then after that, if we want, we can go, okay, we're down here, right? So here's the triangle that I'm drawing. So I'm trying to find theta. Theta is the unknown measure. So cosine, well, I'm just going to label the sides. Cosine, we know, is what? Adjacent over hypotenuse, right? So adjacent would be 5, and hypotenuse would be 12. Or sorry, 13. I just gave the answer. Hypotenuse is 513. Well, if you do Pythagorean theorem, if you do a squared plus b squared equals c squared, right? That's what I'm doing. I'm doing a squared plus b squared equals c squared, and I do the math, then I'm going to find out that this right here is 12. So this is from Algebra 1, so you guys can do this really quickly. So now I know it's a 5, 12, 13 triangle. Then what I would do is fill it in. So I'm trying to find sine. So sine theta is going to be what? Opposite over hypotenuse. So opposite over hypotenuse. Well, what is sine? Well, y, if we're in this quadrant, y is negative. So there is that. Then tangent theta is y over x, right? Y over x. So it's going to be y, which is we now know is going to be a negative 12 over a negative 5. So that's going to be 12 this tangent. Or you know that two negatives make a positive, so you can just go straight to that too. I'm not sure if we want to do another one. I think that's good. If you want another example, I'm happy to do more. Just let me know. I will talk to you soon.